So what we're going to do now to kind of wrap up the overview of streams is we're going to talk a little bit about the differences between so-called external and internal iterators in Java. And you'll see that Java programmers historically have iterated through collections, arrays, or various kinds of collections in the Java collections framework by using so-called external iteration. So a good example would be the Java for each loop, which exists obviously outside of any collection, and it invokes application-supplied code on each of the elements in the collection during the external iteration process. So if you think about what's going on, we've got ourselves a collection with a bunch of elements in it, and we have the for each loop, and then you have application code that gets called as you go along. So let's take a look at a very simple example. Here we've got a list of strings, which is an array list, Larry, Curly, and Mo. And what we're going to do is we're going to use the for each loop to walk through every element in the collection externally. And for each name in names list, we're going to go ahead and do something to each of the elements. So for each name, we're going to go ahead and print it. So you can see how the for each loop is external to the collection, and you basically get each element back from the implicit iterator that's being used here for the for each loop, and then we go ahead and take the result, each name, and we print it. You could also use a Java iterator in order to iterate through a collection externally. So here we make ourselves an iterator by using the factory method on names list for every element that's there until we run out at the end. We're going to go ahead and get the next element, and then we're going to go ahead and perform some action, in this case, printing it. That should look pretty intuitive. Most people have written code like this. I've certainly written code like this back in the day before I became wise to the ways of Java streams and functional programming. So let's take a look at an alternative way to do things using internal iteration as opposed to external iteration. So in contrast to a for each loop in a collection, a Java stream will invoke app-supplied code on each stream element during the internal iteration process. So you can see here that we've got a Java stream, and you've got elements in the stream, of course. And then you've got app code, which is passed into the stream, and then the operations are performed on that code in the context of a stream. So it's done internally as opposed to externally. Here's a very simple example using the same style that we looked at before, where we've got an array of strings, which we turn into a list. And so you can see what we do here is we basically convert the names list into a stream by using the stream factory method. And then for each element in the stream, we're going to go ahead and perform some action on each of the elements. So again, the for each method is being used in the stream. It keeps track of the elements that are in the stream, and it internally applies each of the method. It applies the method reference that's passed as a parameter to for each of the elements that is part of the stream. So that's what's called internal iteration as opposed to external iteration. Okay, so we'll talk more about that, of course, and look at some more examples. Now, this distinction between internal iterators and external iterators becomes particularly important when stream pipelines become more complex. For something as simple as just looping through the elements of a collection, there isn't really that much difference. But when we start getting into things like we're about to look at here, it becomes a lot more useful for a whole variety of different reasons. So you can see here that we take a URL array. If we have an array of URLs, we convert that array into a stream. And then we're going to go ahead and replace the substrings in the stream. So for each string S, we're going to take a look and see if it contains the substring cse.wustel, which was my old URL domain name when I was a professor at Washington University. And we're going to replace that with dre.vanderbilt. And then we're going to pipe that into the map operation. And then what we're going to do is we're going to convert the string URL into a URL object of type URL, all caps. And when we're all done, we're going to collect the results into a list. So you can see now that we're internally iterating. You don't see an iterator explicitly anywhere. You basically have this all being done in external iteration. One thing to note, by the way, is when you start dealing with streams, you'll discover that checked exceptions are very awkward. So it turns out, for instance, that the constructor for the URL class will throw an exception if the URL that's given to it is an invalid URL. And while that's sort of useful, actually it's very useful to get an exception back, of course, from a constructor, a checked exception means that without doing anything to the contrary, we're forced into this really odd kind of try-catch ugliness inside of the body of the map parameter. And that's just ugly looking. There are various ways around this. Probably my favorite way to do it is to use something called exception laundering. It sounds like money laundering, but it's not as illegal. And exception laundering basically uses an adapter to convert some type that expects or uses a checked exception into an equivalent behavior that will use runtime or unchecked, I guess not unchecked exceptions, it's runtime exceptions. It's not statically checked exceptions. And so you can see here that we do this by applying a Rethrow function adapter, which you can read about in the link at the bottom of the page. And what this Rethrow function adapter does is it takes in a parameter that will throw an exception but has a function signature to it, where you have a parameter type and a return value, one parameter, one return value, of course. And what it does is it goes ahead and it will wrap the function that throws an exception internally to the Rethrow function adapter method, and it will apply the function, catch whatever exception happens to be thrown, whatever that might be, and then it will go ahead and throw that exception as an unchecked exception as opposed to a checked exception, or a runtime exception is probably better. It checks it, but it doesn't check it statically, syntactically. It checks it dynamically by doing the exception handling mechanism as a runtime exception. And so what's nice about this is we no longer have to write this kind of hideous, ugly code, but instead we can write code like that. And there's a lot of benefits to doing this. You'll see that a lot of the modern Java classes now have come up with alternative methods that don't use checked exceptions, but instead use runtime exceptions. We'll see an example of this later when we talk about the completable future framework. The old school future class had a method called get that would have a checked exception. The modern completable future class has a method called join that has a runtime exception. So you can use it more conveniently without having to use this type of exception laundering mechanism in your code. Okay, so that's the overview of external versus internal iterators and iteration in Java, and we'll get a chance to learn more about the pros and cons of this approach in our next video.